Hi, Year 8. Today we're going to have a look at some examples of equations with fractions. So this just means that we need to get rid of the denominator before we go on to any more steps of solving our equation. So you're probably already pretty familiar with most of what I'm going to go through, but I'm going to go through 3 quick examples just to show you how it's done. So, equations with fractions. Our first example is 3x over 7 equals negative 6. Now here, our first step needs to be to get rid of this denominator. So if we have 3x divided by 7, what we're going to do is times both sides by 7, which means the 7 will be gone, and on the left we'll have 3x equals 6 times 7 is 42, so negative 42. Then I have 3 times x, so to get rid of that 3, I'm going to divide both sides by 3. So I'll end up with x equals negative 14. So that's my solution there, nice and straightforward. With example 2, there are 2 possible ways of solving this. They both get you to the exact same answer, but I'm going to show you both, just so that you've seen it. Now, this one has an unsimplified fraction to start with, but just bear with me on this one, because I'm using it specifically to show you 2 different ways of working this out. So, the first way is to get rid of this minus 1, because this is a constant out on its own. We always start on the side where the x is, and we, from last lesson, know that it's useful to get rid of that constant term first. So what I'm going to do here is I'm going to plus 1 to both sides. So 5 plus 1 gives me 6 on the left. Once that 1 is gone, I'll just be left with the fraction. Then I can get rid of the denominator. So I'm going to multiply both sides by 2. I end up with 6 times 2 is 12 on the left equals 4x on the right. And then I know if it's 4 times x, I divide both sides by 4. And I end up with 3 equals x, and you might like to rewrite that as x equals 3. It's nice to have the x on the left, you don't have to. Now, the other way of solving this equation is to get rid of the denominator first. But because this doesn't have a denominator, what I'm going to do is I'm going to multiply everything by 2. So it's not just this fraction and then the other side, it's all 3 terms in this equation. So when I multiply by 2, I'm multiplying everything on the right-hand side by 2. So on the left, 5 times 2 is 10. Then 4x over 2, that 2 will cancel out and I'll just have 4x. And then when I times the minus 1 by 2, I get minus 2. So that's really important when we're multiplying. You multiply each individual thing. That wasn't something we had to worry about over here because there were no pluses or minuses. So now it just looks like a 2-step equation from last week. We're going to get rid of the constant, so we're going to plus 2 to both sides. And I end up with 12 equals 4x. And you can see from this point, it's just this line. So same number of steps, it's just a different way of starting. Okay, I'll leave that one there. You guys can finish off the writing for that if you want to. Example 3 is when we have a plus or minus in the numerator of our fraction. So I'm going to do x minus 11 all over 5 equals 20. Now, here we don't really have a choice. We can't do anything with this numerator until the denominator's gone. So I'm going to start by multiplying both sides by 5. That leaves me with just the numerator on the left, and then 20 times 5 is 100 on the right. Then all I have is this plus 11, or the minus 11, sorry. So I'll do the opposite. I will plus 11 to both sides, and I end up with x equals 111. Now, as you go through these equations, hopefully you're checking your answers as you go to make sure that you are on the right track. In an exam, what you would do is, if you had time at the end, or as you were going through each question is probably a better way, you would take this x equals 111 and you would check your answer by subbing in to the original equation. So you would grab your calculator and you would write 111 minus 11 over 5, and you would double check that that gave you an answer of 20. And if it didn't, you would know that something had gone wrong and you would go back and start again. So subbing into the original equation is a really good way of checking your work.